This is Math 2, Lesson 523. We're going to be completing the square in this lesson. We're going to be writing here. And so we're going to figure out, we're just going to practice what we did in class today. So in class on Monday or Tuesday in February 1st or 2nd. So we're going to solve each quadratic equation by using tiles and algebra. I'm going to focus on the algebra here because I think we focused on the tiles in class, so we're going to focus on the algebra. And so, because the tiles get a little bit funky and kind of painful sometimes, so we're just going to focus on the algebra behind this. So what we're going to do, the very first thing we're going to do is take our equation, which I'm going to rewrite. I'm going to use a different color. And the very first thing we're going to do is move the 7. So we have this equation. We're going to start by subtracting 7 from both sides. And so we have x squared minus 6x squiggle equals negative 7 and squiggle. Now, squiggle is my very formal way of saying we're going to add something to this. So we need to force this thing into a perfect square. And we're going to add the same number to both sides because it's easier that way. So, like, if you think about it, and let's go ahead and play with the tiles for just a minute. No tiles. So we've got x squared. And I should get more of this out. I should have done that extra. That's okay. Okay, so here's the deal. When I'm building the tile, I'm trying to make a square. So I've got x squared, and I've got 6 negative x tiles. So I'm going to flip these all over to negative. So I've got these 6 negatives. Now I need to make a square. So what I'm going to do is I'm going to split this in half and put like so. And so what I like to draw on my paper, because I'm not going to draw that carefully, is I just draw a box, an area model problem. So this is x squared, and there's 3x here and 3x here. So what has to be here so it's a square? So in other words, what would I have to put right there to make a square? Well, it's 9. And so that's my addition to the problem. So when I think about what's happening here is I'd have these 7, which I would have moved across. And so I have the negative 7, and I have to add 9 over here too. So I didn't really change anything. So 9 is my number. Now let's talk what we did algebraically. So we've got our picture to help us, but what we did is we split this in half. So we take this middle number and we split it in half. Let me do that in a different color. So we split 6 in half. So negative 6 divided by 2, which gave me negative 3. And so those are my numbers on the sides of my rectangle. Let's bring that up. And so those are my numbers on the sides because I split it in half. And so when I write the edges of this, we've got x minus 3. That was not clear on these. And x minus 3. And so this becomes x minus 3. The half right there is in my parentheses squared because there are 2 of them. And then on the other side, because I've added 9 on this side, I must also add 9 on the other side. So that didn't actually change anything because what you add to both sides and it's the same. We've done that before when we're doing solving steps and we subtract 6 from both sides. That's why we do that. It keeps it the same. When we don't move the 7, then we have it on the same side, and that's a little bit trickier. And I don't like to do it that way. I only do that way when I'm showing people the first few times and I don't know that. So there we are. And so over here, this whole thing, if I was to build a diamond and try to factor it, let's go ahead and do that. So we'd have our diamond in our box. And so we'd have x squared. Well, that's just dreadfully drawn. And 9 right here, right? So we'd have 9. And I did that backwards. That's the way I'm used to. And so this number is negative 6. And so that's negative 3 and negative 3. We look at our edges, x minus 3, x minus 3, so that's why we have x minus 3 squared. The other side, really simply, just becomes equals negative 7 plus 9, which is 2. So what happens to this negative 3? Two things. To get the squiggle, I take the half number and I square it, which is equal to my squiggle. Which in this case was 9. And so that squiggle's on both sides, but this is the thinking I did. So I don't always write the thinking down. I'm writing it down because we're explaining. And that's it. There's my answer. Okay? Now, does it just solve it? We'll come back to that in a minute. Right now, we're just going to leave it here, and we're going to go ahead and try again. So for B, I have 2 p's. There they are. So I've got p squared and p, 2 p's, and then this plus 1. So again, algebraically, the first thing I do, that is not a p. The first thing I do is move the 1. P squared plus 2p squiggle equals negative 1 squiggle. So looking at my picture, I've got these and I've got to split them in half. Split them in half. So I'm going to get, splitting it in half, I'm going to split 2 in half. That's going to give me 1. And then I'm going to square 1, which will give me my squiggle. And so this time, 1 squared is 1. My squiggle is 1, plus 1, plus 1. And so this becomes this. I drew my picture over here. This is just a 1 that I need. Okay? And so this becomes x plus 1 squared. Again, 1 being half. This half 1 came down here. This half 1 came down here. Okay? Half 1 goes right there. And then over here, wrong colors, we get negative 1 plus 1 or 0. And I'm finished. One more. I want you to try it on your own. I'm going to give you the hints by putting the tiles up. We've got x squared, or k squared in this case, for negative 4. So we're putting these to negative, and 9. Give you a couple more hints. First thing we do is rewrite it. Minus 9 from both sides. So first thing I want you to do is figure out what is squiggle. Or in other words, what number am I adding to both sides? So I take this, split it like that. And if you need to draw it, go ahead and draw it. Whoops, k squared. Should have been p back here. Negative 2k, negative 2k. What has to be right there? How many tiles do I need in that space? Well, 4. I need 4. Making squiggle 4. Over here, negative 4 divided by 2 is negative 2. Negative 2 squared is 4, so that's where my squiggle came from. Okay. And so I have on this side k minus 2 squared, again that 2 coming straight down, equals negative 5. Okay, so that's that. Now let's solve. Let's actually solve that where we are. So this one has what? I'm going to take the square root of both sides. K minus 2 equals plus or minus radical negative 5, which means no real solutions. Done. here, take the square root of both sides. X plus 1 equals plus or minus radical 0, which is just 0, because it's not positive or negative. X plus 1 equals 0. X equals negative 1. And then this one, go ahead and solve that one on your own. Take the square root of both sides, plus or minus radical 2, at 3. X equals 3 plus or minus radical 2. Yep. All right, so that's it for this video. I hope that is helpful. We will practice this some more in class. Have a great day.